Hello again. This is another example of a non-homogeneous higher order equation, specifically the g of x, or the function that can be found on the right hand side, is trigonometric in nature. Specifically here, it's a sine a function, which is a part or example of a trigonometric function. We can solve this non-homogeneous higher order equation following this formula: y is equal to y sub c plus y sub b. Now, y sub c is known to be the complementary solution if this g of x is equal to 0. Hence, we will be using the same methods of solving homogeneous higher order equations. We're going to come up with the auxiliary equation of this, solve for the roots, and refer to the roots as to what type of general solution will come out on y sub c. Now, y sub b is known to be a particular solution for specific coefficients following this given table here. We are going to use these representations for a y sub b depending on what is our g of x. And since our g of x is trigonometric, we're going to refer on the 5th and the 6th row. Specifically here, we are going to use the 5th row because it uses the sine trigonometric function. In short, the form of y sub b, which we are going to solve later, is in the form of a cosine of, take note that this is 3x here, so cosine of 3x, because we need to follow the angle being described, plus b sine 3x. Later, we are going to solve for a and b coefficients so that we could solve for y sub b, the particular solution, which will be paired to our y sub c. So let's start solving with y sub c. As mentioned, we're going to use the same process of solving higher order homogeneous equations. First is to come up with the equation with a differential operator d equating it to 0. Hence, our left hand side will become d squared minus 16 times y equal to 0. Again, this is for our y sub c process. That would mean that its equivalent homogeneous equation is expressed as m squared minus 16 equal to 0. Let's solve for the roots of this auxiliary equation, and since this is an example, the right hand side, m squared minus 16 is an example of difference of two squares, our factors could be m plus 4 and m minus 4. With this, our first root is equal to negative 4 and our second root is positive 4. Since our roots are distinct and they are both real, we are going to use the general solution for situations of the roots of our auxiliary equation being equal to distinct or real roots. The form that we are going to follow here for our y sub c is in this manner: c sub 1 e to the power of m sub 1x plus c sub 2 e to the power of m sub 2x. We only have two terms because we only have two distinct roots here. So we simply plug in the values, considering c sub 1 and c sub 2 just any arbitrary constants. We will have here our y sub c is c sub 1 e to the power of your first root minus 4x plus c sub 2 e to the power of your second root 4 times x. Now, you don't need to worry if you were able to write m sub 1 as positive 4, not negative 4. So you'll be changing this and that. Nevertheless, they are actually commutative, and being c sub 1 and c sub 2 be arbitrary constants because you simply rewrite them in any order. So this is our y sub c. Okay? So this is just the first part of our solution, because we are going to look into y sub b. Again, we're going to look for the coefficients a and b following a specific method where we are going to come up with this y sub b as mentioned: a cosine 3x plus b sine 3x here. Since our original equation is of second degree, we're going to take its second order derivative, which will be which of course derive both sides of the equation. So first, our first order derivative is the derivative of that. Since it is just constant, so we only have a times the derivative of this function, cosine. Take note that the derivative of cosine is minus sine with the same angle, 3x. But since our angle here is not just any angle, it's a 3x, according to the chain rule, we also need to take the derivative of that angle, and that's actually equal to 3. Okay? That's just for the first term. Plus the second term, b, still b. Then the first derivative of the derivative of sine x is cosine 3x. And similar to what happened earlier, the angle is a 3x, so its first derivative is also 3. This is according to the chain rule. So with that, our first order derivative of y sub b can be written as minus 3a sine of 3x plus 3b cosine of 3x. So we'll be using that later. Take note that, again, as mentioned, the highest degree is 2, so we still need to take its second order derivative. So let's derive this. So we'll have here y double prime of p is, again, taking a derivative of this, considering this as constant, so we'll be leaving that later. So you will have still minus 3a here, and then the derivative of sine 3x is cosine 3x times the derivative of this angle 3 according to chain rule, plus this is still 3b. Then the derivative of this is sine 3x times the derivative of the angle 3. The derivative of cosine should be minus sine 3x. So please take note of those signs as well. So simplifying this, the second order derivative is you have minus 9a cosine of 3x plus 9b. It's now minus because we have negative sign here. So minus 9b sine of 3x. So this is our second order derivative. This is our first order derivative. This is our y sub b. We only need this because we are going to substitute y sub b on our original equation here, equating to our original g of x, which is sine 3x. So again, let me copy here the original form. This is second degree. Minus 16y is equal to sine 3x. So the second order here derivative will be this one. We don't have the first order derivative. The y here would be y sub b given by our table earlier. So it would look like this. Please bear with me. Our second order derivative will become y sub b minus 16y sub b is equal to sine 3x. We are going to do this to solve for our coefficients a and b needed for our y sub b to be paired with our y sub c here. So it would take a longer period of time, but let's just do it anyway. So you have minus 9a, this one here, cosine 3x minus 9b sine of 3x, that's the angle, minus 16, and your y sub b was this a and plus b. So you have a cosine of 3x plus b sine of 3x. These are all equal to your sine of 3x. Take note that our right hand side is just sine, so we need to group all trigonometric functions on our left hand side together with all the cosines and sines. So we'll have here minus 9a cosine of 3x minus 9b sine of 3x. This will become minus 16a cosine of 3x, then minus 16b sine of 3x equal to sine of 3x. So let's group them all. Let's start with the cosines and factoring cosine 3x. Okay, so you will have minus 9a minus 16a, or you can just simply combine them. Let's combine them first. Okay, minus 9 minus 16, so you have minus 25a cosine of 3x. And for b, you also have minus 25 cosine, minus 25b. Okay, minus 25b, because that's minus 9 minus 16. It's now sine here. Sine of 3x equal to sine of 3x. This time, notice that our right hand side rather, only contains sine. So we can equate this with this one here. So what would be the equivalent of cosine? It automatically, understandably, we can write here 0 cosine 3x. Hence, this is just equal to 0. So you can have those equivalents because we can use that to solve for a. So you have minus 25a cosine of 3x is equal to 0. And for your b, minus 25b sine of 3x is equal to sine of 3x. So we are solving for b. Of course, here, this will only be true if a is equal to 0. Here, dividing both sides by minus 25 sine of 3x to cancel this. You also have here minus 25 sine of 3x, which you can cancel. So b is just equal to negative 1 over 25. In short, with this a and this b, your y sub p, sorry for that, don't have much space, y sub p, which is expressed in this form, a cosine 3x plus b sine 3x is your a. So it's 0 cosine of 3x plus your b, negative 1 over 25 sine of 3x. This becomes 0. So y sub p is just equal to negative 1 over 25 sine of 3x. That is your y sub p. In short, for our y, I don't know if my space is enough. This is our y sub c plus y sub p. So we'll be taking this minus 4x and plus 4x for the exponent of our e is just equal to, supposedly this is y sub c plus y sub p. Take note of that. Y sub c is c sub 1 e to the power of minus 4x plus c sub 2 e to the power of positive 4x. Then your y sub p minus 1 over 25 sine of 3x. So this is now the general solution for our given non-homogeneous higher order equation, where our right hand side is identified as a trigonometric function sine of 3x. So again, this is the solution, and we had a lot of process reaching to this one here. So take note of all of these things. Thank you very much for watching.